All right, ladies and gentlemen, today's class recording has started. So, on Friday, we were in the library. We were making graphs of the measurements of position and time that you took down in the PAC on Thursday. Okay? So first, generally, right, graphing motion. Why do we make graphs? Just in general. Organized way to show data, and what about that data specifically? The patterns, the relationships that are there, right? It's easier to see those a lot of times when we do them as a graph than if we're just looking at a bunch of numbers. Okay? So we're going to talk about two graphs. We're going to talk about position versus time graph and velocity versus time graph. So let's start with position versus time graphs. In a real, like, well, yeah, duh kind of way, what is a position versus time graph going to tell us? Position and time, right? So it's going to answer two questions for us. What questions is it going to answer? Where is it? And when is it there, right? Where is an object at what particular moment in time? Okay? That's a position versus time graph. We'll get to velocity versus time tomorrow. Here is a picture of two swimmers and a position versus time graph for the two of them. You'll notice you have a copy of that picture on your lab there, or on your notes. And in the bottom left-hand corner, there are 4 questions to answer using that position versus time graph for the two swimmers. So why don't we take 2 minutes, talk to the person next to you or in front or behind you or whatever, and answer those 4 questions. Go. All right, 30 more seconds. All right. So let's discuss. Remember, position versus time graph. And over here on the side, this graph is actually labeled as distance because I got it out of a book and that's what the book had. So, but let's think of it as position, right? So we said that a position versus time graph tells us 2 things, right? What does it tell us? Position and time. Where and when, right? So the when in this problem is 20 seconds, right? How many of us put 40 meters for the where? How many of us put positive 40 meters for the where?
Without the sign, it is positive.
True. No.
Yes.
No.
Yeah.
Let's get in the habit of that, right? If displacement is a vector quantity, right, we should indicate direction. Somehow, some way. No, there's no implication here. So, right? So, positive 40, right? Which side of the reference point are we on? Okay? Number 2. How far ahead of swimmer 2 is swimmer 1 at 20 seconds? Now in this case here, what is this question just asking you for? Distance, right? How far? Does that need a positive or a negative? That one's just a distance, right? So a scalar. So you don't need that positive or negative there, right? All right, what is the displacement of swimmer 1 from 10 seconds to 40 seconds? Displacement, right? We need to know two things. What are the two things we need to know? Starting and ending, right? So in this case here, the starting point is here and the ending point is there, right? 10 to 40, okay? So when we calculate where we end up versus where we started, we should end up with 60 meters, right? Positive 60 meters, right? Because displacement is a vector. It needs direction. Which way did we go 60 meters during that time frame? Okay. And finally, which swimmer is faster? How can you tell? Well, which swimmer is faster? Swimmer number 1 is faster. How can we tell that swimmer number 1 is faster? Okay. Let's go first with just looking at the graph, right? What does this graph tell us about how far swimmer number 1 went versus how far swimmer number 2 went? Yeah, swimmer 1 covered a greater distance in that time than swimmer number 2 did, right? Okay. In order to calculate that, we throw some numbers on the graph, right? And Jason, the slope part is important here in just a second, right? We'll get into that, okay? All right, so first, let's fill in just some details, okay? Position versus time graph. Position versus time graph tells us the location of an object relative to a reference point over a specified period of time. When we make position versus time graphs, time is going to go on our x-axis, and position is going to go on our y-axis. Right? So each dot on the graph tells us two things. It tells us time, that's going to be our x-coordinate, and it tells us position, that's going to be our y-coordinate. Okay? Good there? All right. But there are some other things that we can get off of this graph. For instance, right? The first question, we found position, just where and when. But we can figure out displacement by looking at where it was versus where it ends up. And finally, we can talk about the velocity of an object by examining how far did it go and how long did it take to go that far, right? So, just real quick in your head, what is the average velocity of swimmer number 1? If it's velocity, it's actually, no. If it's velocity, what does it need?
Positive.
It needs a direction, right? So swimmer number 1, her velocity is positive 2 meters per second. Edie, how'd you do that?
Because you take the time, so like it doesn't matter anything.
True.
Divided by the time.
Okay. Okay. So it went 100 meters and it took 50 seconds to go there. That's 2 meters per second, right? But mathematically, Edie, what did you just calculate about that line? You just calculated the slope, right? Yeah. Way back in 6th grade or whenever you start taking pre-algebra or whenever that is, right?
Pardon the interruption, just one quick athletic announcement. The
Easy.
Westlake
There's
Student
still
Athletic Leadership Council will
like
meet
7
tonight
minutes
at
left to
7 p.m.
school.
in the Red Brick Room. If you don't know what that is and you're interested, please be there at 7 p.m. in the Red Brick Room. Some of you may have been invited by your coaches, and we will see you there. Have a great day. Go Dean.
What time is it?
7 o'clock. Yes, we're on homeroom schedule tomorrow. So, not homeroom at the beginning of the day schedule. Okay. So our normal homeroom schedule, you go to first period, and then first period ends a couple minutes early, and then you go to homeroom in between first and second period.
Oh, so it's not an hour long.
It's not an hour long. No, it's going to be 7 minutes long.
Wait, when?
That's it. Tomorrow.
We have homework tomorrow?
You have homeroom tomorrow. But homeroom, on our normal homeroom schedule, is after first period.
They didn't say that.
Yeah, they sent us an email. So So yeah, don't worry. At the end of first period tomorrow, your teacher's going to say, "Hey, go to homeroom." So you know, so. I mean, like each period is shortened by 1 minute. So you, there's like 1 minute off of each period, and we get like an 8-minute homeroom. So that's.
Why do they
Tomorrow you're going to get your pictures, and you will be voting for homecoming king and queen.
That's gonna be me.
All right, so. All right. So, back in whatever pre-algebra, you talk about the slope, and we define the slope as rise over run. But mathematically, we represent the slope as delta y over delta x. Okay? We learned that the delta means what? Change, right? So the change in the y-axis is how high it goes on the y-axis. Delta x is how far it goes on the x-axis, right? That's rise over run. Okay? If we talk about this graph specifically, this is just a general math expression, delta y over delta x. But here, on the x-axis and the y-axis, we're actually measuring something. What are we measuring on the y-axis here? The distance, or technically the position, but distance, right? And we measure that in meters, right? What are we measuring on the x-axis? Time, and we measure that in seconds. So in this graph, even though it's a generic delta y over delta x, if we assign values to the y variable and to the x variable, the y variable we measure in meters. The x variable we measure in what? Seconds. So if we have meters over seconds, what does the slope of this graph tell us? Amount of meters per second, which we call the velocity, right? In this case, because we could have slope this way, or we could have slope this way, right? And that's going to be a negative or positive, which means direction is important there, right? So the slope on a position versus time graph tells us the what? The velocity of that object, right? So right underneath this little expression, okay? What are the units on the slope of the position versus time graph? Meters over seconds, right? Meters per second. And then, that being said, what does the slope on a position versus time graph tell us? The velocity of the objects. Okay? Good there? All right. Why don't we cut it off there, and we'll get into examining some of these graphs tomorrow in class. You just did it. Oh, sorry. One reminder, just because we're on the recording, right? Don't forget, there are a couple of pages from the book that I would like you to take a look at tonight. It reviews some of the things that we talked about today in class, and it will introduce you to velocity graphs, which we'll talk about tomorrow. Okay? So, don't subscribe to Doodle King. Subscribe right here. That's what you need to do. So.